Hey, all you cool chemistry cats. Miss Macaulay's taking a break, so it's Oliver, and I'm going to teach you all about Dalton's law of partial pressures. So, get out your calculators, make sure you've watched your notes, watch your notes first, and don't go petting any cats. Only corgis. Yay! Okay, let's go to the notes. Uh-oh. Okay, Dalton's law of partial pressures is super easy. Make sure you've watched the video notes on this first. And the equation is P total, the total pressure of the whole system, is equal to the sum of the parts. The partial pressure 1, partial pressure 2, partial pressure 3, and so on. You can add up as many partial pressures as you need. And then, one thing to keep in mind is when we're adding or subtracting sig figs, you want to maintain the least number of decimal places. So it's not total sig figs, least number of decimal places. So make sure you've got a calculator, and I need to go make sure Pickles is quiet. Start this problem, and then pause, add up, and check back with me in a moment. Okay, welcome back. Number 1 says a metal tank. Now the metal tank, that's the whole system. Okay, that's the closed system. That's going to be our P total. I'm writing P total in black. And then it's made up of 3 gases, oxygen, helium, and nitrogen. I'm going to use that same color coding scheme. So the first partial pressure listed, I'll use red. The second partial pressure, I'll use blue. And then the third partial pressure, I'll use green. And then I'll round for sig figs with orange. So if the partial pressure of the 3 gases in the tank are 35 atmospheres of pressure for oxygen, so 35 atmospheres for oxygen. My second, now this one is flip-flopped. Here I had helium second, so I'm going to keep helium second right here. 25 atmospheres of pressure for helium and 5 atmospheres of pressure for nitrogen. What's P total? Well, what do? We add all of them up. So use your mental math or use a calculator, and you should get 65 atmospheres. Let's look at our sig figs though. When we're adding or subtracting, least number of decimals. 35 has no decimals. 5.0 has 1 decimal place. 25 has no decimals. So the least number of decimals is no decimals. 65 is my final answer. That's why I've circled it there in orange. Okay, that's an easy one to get started. But if you got that one, you're going to do fine because everything else on this page just uses the same concept the whole time. Make it a little trickier because we do some fancy math things, but it's the same concept. Okay, problem 2. Blast furnaces give off many unpleasant and unhealthy gases. They're used in industry for things like refining iron and other types of stuff. But if the total air pressure is 0.99 atmospheres, so in the whole furnace, it's almost 1 atmosphere, the partial pressure of carbon dioxide is 0.050 atmospheres, partial pressure of hydrogen sulfide, H2S, our old friend stink damp, is 0.02 atmospheres. What is the partial pressure of everything else that's in there? So this time we know total, and we know some of the parts. We're looking for one of the missing parts. So let's take a look at how we'd set that up. So the P total is 0.99. We know that the carbon dioxide is 0.050. We know that the hydrogen sulfide is 0.020, but we don't know what the remaining extra air is. So that's our unknown right now. So how would we isolate and solve? We're adding. So how do I get remaining air by itself? I would subtract these over. So take a second in your calculator, your handy dandy calculator of science. You want to find your calculator. We have 0.99. We need to subtract out the 0.050. We need to subtract over the 0.020. We're left with 0.92. Let's see if I agree with. Yep, 0.92 atmospheres. That's the other stuff in there. A bunch of other different types of gases. Don't worry about what they are. Do I have the correct number of sig figs though? Adding or subtracting, least number of decimals. So let's look right here. 2 decimals. 3 decimals. 3 decimals. This was my least number of decimals, so I've got to keep it there. That's my final sig fig answer. Okay, number 3. Air is composed of several gases. The partial pressure of nitrogen is 593.4 millimeters of mercury. The partial pressure of argon is 0.0093 atmospheres. The other gases, besides oxygen, total 0.31 millimeters of mercury. What is the partial pressure of oxygen at mean sea level in kPa? Ooh boy. This is going to be a fun one. Same concept, but the person who wrote this problem wanted to test you. Couple things. So what is the P total? They're talking about air at average or mean sea level. That means the P total is 1 atmosphere. However, they want the final answer in kPa. If you go back to page 1 in your conversion factors, 1 atmosphere is 101.3 kPa. So before I even start, I know this. Ooh, whoa, that was weird. I know my total pressure is 101.3 kPa. But what's the problem? I'm adding apples and oranges here. Can you add millimeters of mercury to atmospheres? Nope. So we've got to go back to what we did on page 1 and get all of these into the same terms. You can pick any unit you want, but keep in mind the final answer they're looking for is kPa. So let's just save ourselves some work, put everything into terms of kPa. Okay, looks like a lot, but don't panic. Total pressure is equal to the partial nitrogen plus the partial argon plus the partial other plus oxygen. What I have right here is just the factor label setup, okay? So I've got my nitrogen, 593 millimeters of mercury, and here's my conversion factor, 760 millimeters of mercury for every 101.3 kPa. I want you to write that down. Then for my argon, I got 0.0093 atmospheres. My conversion factor on that one is 1 atmosphere to 101.3 kPa. And then for my other gases, I got 0.31 millimeters of mercury. That conversion factor, just like over here, 760 to 101.3. I want you to pause the video, solve these problems, and rewrite it below, then come back. Thank you, those of you who really paused the video. Everybody else, Ollie's sad for you. Okay, so let's look at what's rewritten here. P total. I guess I could write that for you. I thought you could figure it out on your own, but let's be specific here. So this is my P total. This is my P nitrogen, P argon, P other, P oxygen. Okay, so when we convert this, what's the partial pressure of nitrogen? The partial pressure of nitrogen should be 79.09 kPa. On this conversion factor, I want to keep the least number of decimal or least number of total sig figs, so I got 4 sig figs there. But really don't round till you get to the very end. For argon, we should have gotten 0.94 kPa. For the others, we should have gotten 0.0041 kPa, plus the missing oxygen. See how this is just the same thing? We've just put it all in the same terms. We're comparing apples to apples now instead of apples and oranges. So total equals all these pieces plus an unknown. How do we get that unknown by itself? Subtract. So take it some time right now. Take 101.3, subtract 79, subtract 0.94, subtract 0.04, and add them all, or subtract them. What do you get? You get 21.229. But looking at all these numbers, we need to have the least total number of decimal places. This is the one where it gets kind of weird. If you want to get technical, we are infinitely certain about this, but we used it as an input into the problem. It has 1 decimal place. Everything over here had at least 2 decimal places, but we had also rounded up here. So this, so this one, oh, Pickles is barking again. So this one, I won't be too fussy on it. Let's go to 1 decimal place. You could go to 2, 21.2 kPa. Oh, Pickles. Okay, number 4 says a 250 milliliter sample of oxygen is collected over water at 25 degrees Celsius and a 750.0 millimeter mercury pressure. What is the pressure of the dry gas alone? You have to go back to your video notes for part of this, okay? Because we talk about collection of gases over water in there, and we have to take into account the vapor pressure. So P total is going to be the oxygen plus water vapor is going to evaporate up, okay? So let's plug in what we know. So we know that P total is 750 millimeters of mercury. We don't know the oxygen, but the water value we can read off of a table. So how do we solve for this? We just subtract, okay? And then we want to have the least number of decimal places. We're just subtracting 1 decimal, 1 decimal. We're going to go to 1 decimal place. Okay, setup number 5. I'm going to go see what Pickles is barking at, and we'll be back. Okay, we're back for question 5. So, what do we know? We know that the total pressure of the system is 1.03 atmospheres. Let's be specific. We're going to label that as pressure P total, and that's equal to the pressure of hydrogen plus the pressure of the water vapor. Now, here's where it gets a little tricky. We are told the total pressure in atmospheres, but when you look up your vapor pressures of water, this one was given to you in millimeters of mercury. We've got to put everything into the same terms. It doesn't ask for a specific unit here, so I just went in this direction. You could have, of course, converted this one to millimeters of mercury if you wanted to. It's all the same. Just, whatever is easiest as long as you're following the directions in the question. So 1.03 atmospheres is going to be equal to the partial pressure of hydrogen. Now, I took what I knew over 1, and I want to cancel out millimeters of mercury and go to atmospheres. If this confuses you, go back to your notes on unit conversions, go back to the page 1 video that Pickles did for you all. You should get 0.02309 atmospheres. So how do I get P hydrogen by itself? Well, I just subtract this over. So you should get your partial pressure of hydrogen is 1.00691 atmospheres, but we need to go to our least number of decimal places, which looks to be see now here we got 2. Let's see what I did here. Come on. Okay, this one doesn't want to delete. Try it again. 1.01. Good, I did it right. So 2 decimals here, 2 decimal places here. We can ignore the temperature. That wasn't part of the input into this problem. That was just for looking at the grid in your notes. Let's see if I'll delete now. Oh, there it goes. Okay, now we're down to the very end. Let me extend the screen to get it centered in the frame. Oh, too much. An 8.9 milliliter sample of butane, that's the same gas that's in little like Zippo lighters, is collected over water at 15 degrees Celsius and at 740 millimeters of mercury of pressure. What is the pressure of the dry gas? That means the butane alone. This is where you have to go back to your notes or use Google and look up the partial pressure of water vapor. So at 15 degrees Celsius, if you check the note table, the partial pressure of water is 12.79. You'll always be given that, or you'll have the chart and be able to look that up. Okay, so we know that P total right here, this is my total pressure of the system, is going to be equal to the pressure of the dry gas, which is the butane, plus the partial pressure of water. So I could label this right here. This is partial pressure of H2O, the water vapor. So how do I get butane by itself? Well, I just subtract this over. When I subtract that over, I get 727.21, but Sig Figs, least number of decimal places. 1 decimal place right here. Well, here from my table I had 2, so this one's going to have to go to just that 1 decimal place. Now we're all done with page 2 of your homework. Ollie is proud of you. Remember, don't wait to be great.